Hey everybody, it's Matt from Eastwood Company. We're here in the Eastwood Garage doing another live tech session. For any of you guys that haven't watched this before, we want it to be as interactive as possible. So we have over here on the chat, we have Randy that you see do a lot of these as well. Randy is manning the live chat. He's going to be answering any technical or product questions you may have. He's going to be saving some of the questions and shooting them over to me throughout. So don't be afraid to ask questions, comment, share. Let your friends know that we're putting up these posts, doing these live tech demos. So today what I'm covering, we have our daily deal that we do on the website every day. Today's daily deal is one of my favorite products, the Eastwood TIG 200 AC/DC machine. This is a really versatile machine that you can weld, do heavy fabrication with, all the way down to real fine sheet metal work. So today, last time I did a TIG welding basics video, we had at least one, if not a handful of questions about welding sheet metal. And I did mention in there that we'd be doing one shortly. So I decided today would be a great one to do a little intro to sheet metal TIG welding. So I have the Eastwood TIG 200. One really cool thing on it, we normally shoot this machine on 220 because I'm usually doing heavier metal when we're teaching you guys how to weld. But today I just wanted to show, this is something I do all the time when I weld for friends. I got our little adapter plug hooked up here. So if you want to convert this machine to 110, all you need to do is take this little adapter plug. This end matches the welder itself. This end goes right into your extension cord, which is running into the wall. That's all you have to do. We're ready for 110. When we flick the machine on, it's going to go, it's going to sense what the input voltage is, and it's just going to make everything happy inside, and we're going to be able to weld. So I wanted to weld in that so you guys can see that it's no problem to weld. I do this all the time when I'm welding sheet metal. It's just on 110 because I might be out in the center of the shop where I can't get an extension cord, my 220 extension cord out to, or I might be at a friend's shop working. So I have the machine, of course, set up on DC because we're welding DC. We're welding steel sheet metal today. I have it on the foot pedal control right now. So I have my foot pedal down here on the table. I have the pieces I have here are just some strips that come in our sheet metal patch panel kit. They are 20 gauge, which a lot of you guys are doing repairs are using 20 gauge or 18 gauge. Because it is the 20 gauge, even when I weld 18, I usually keep my pedal right around 50 amps. That gives me enough amperage that I can have a little bit of extra juice to if I need to, but I can also keep the pedal or the amperage nice and low so I can control the pedal and have it do exactly what I want. You're going to be floating right in that area unless you like having a real light pedal feel. There's no reason to be turning it up to 80 or 100 amps when you're welding something this thin. Otherwise, what it's going to be is you're going to have to be barely on the pedal at all to even get it to be in the sweet spot. So what you want to do is keep it, I like keeping it around 50. That keeps me at about, I don't know, 70 or 80% pedal in this, what I would call a sweet spot where we're welding where we want to be. So that seems to work well for me. So set it there, put the pedal back down where we're using it. And I also have, anytime I'm welding sheet metal, probably more often than not, I have this mini torch hooked up to the TIG machine. I love this thing. It's tiny, it's really light, it's easy to maneuver around when we're welding. And I've referenced it quite often when we're doing beginner videos, but usually it's an afterthought and I don't have it out with me. So what I have is, this is our normal WP17 torch that comes with the machine. Here in my left hand, to your right. And then over here, we have the mini torch, which is a WP9. This torch will handle 110, 120 amps if you start pushing it in short bursts. But for sheet metal welding, it's amazing. You can use it, all day long, no problem at all. Now the consumables, one thing I will mention is, and you have to realize that the consumables are all different on this torch. Everything's different. It's smaller threads. Everything's just micro-sized. So even the collet and collet body inside are smaller. So you can't use any of your parts from your standard torch in this torch. But the nice thing is, generally you're doing detail work with this. This stuff doesn't get damaged and it lasts forever. We just have the standard, when we buy the kit for our mini torch, it comes with a couple different collet bodies. It also comes with these, well actually I'll set them here so you can zoom in. It comes with these, the smaller cups like that. I have a larger number 6 on here, so what do we got, a 4, 5, and I got the 6, which is just a little more of a, it's closer to a gas lens, if you will, with the cup size. They do offer gas lens kits for this. If you go to your welding supply store, you can special order them. They're not something they usually keep in stock, but you can get these for this. But generally, I have no problem using these cups that are on this. It's never really an issue. So now we're done telling you what our setup is here. I'm going to turn my gas on, and we're going to get into actually doing some welding. I'm going to show you some stuff with setup, setting a panel up when you're welding sheet metal, some things you want to do, and also filler rod. This is all stuff that I oftentimes see people make mistakes of when they're first trying to weld sheet metal with a TIG welder. So I have a piece laid here, 2 strips, and Joe, if you want to get in close here, we'll show how we have this set up here. So as you can see, I'm going to use one of these for a pointer. You can see my patch panel for our seam, our weld seam here. There's no gap. Everything's tight together. The fit is real nice. I mean, in this particular instance, I cheated and just got 2 pieces that had a factory cut edge on them that was perfectly straight, so we can just get this all set up and not much prep time for you guys. So you can notice there, this is kind of a perfect situation where we have no gaps. Everything's cut real nice, fits together real nice. There's no gaps. Oftentimes if you're coming from the MIG welding world, a lot of people leave gaps in between the panels so that the weld wire can get in between there and fill up the gap. In this instance, we do not want to do that. We want to be putting as little heat into the panel as we can. If you're thinking of welding something generally with light gauge metal like this, for most of you that are probably watching, you're doing automotive, auto body work where you don't want the panel to warp. You're fighting warpage the whole time. So you want to keep the heat affected zone as small as possible, and you want to keep the warpage down. So if you have a big gap in this panel here and we're trying to fill that gap, that means we're going to have to put more heat into the panel, more filler rod into the panel, and it's just going to cause additional warpage. So as much as possible, keep your gaps to an absolute minimum when you're welding sheet metal or patch panels using the TIG welder. So I have basically no gap in here. Everything's flush. I'm using our little stitch weld magnets that we sell. These things are ridiculously strong. So I'm just trying to hold this panel so it stays flush. So when we're setting everything up, we don't want the panel to shift. I've already kind of trapped it on the ends here. I've tack welded either end of the panel, and when I was making sure the torch was all set up how I liked, I did just a little spot there. But we're using these magnets to keep everything flush. We don't want a gap. We don't want like a lip if we're welding. If you imagine this was a patch panel, you're repairing something, we don't want a lip. We want this to be nice and smooth. Everything's level. Because if you're starting out with panels that are offset from the beginning, it's only going to get worse. They're going to walk over each other and overlap, and then you're really going to be in trouble if you're welding this. You may have to cut the panel and do some other stuff. So by using these magnets, we can really keep the panel under control. It's going to trap it so that the panel doesn't walk around, our weld seam doesn't open. If we started welding this panel and I just started, because I'm left-handed, I would start from the left and go to the right. So if I didn't tack weld anything down here and just tack weld it here and started welding, what's going to happen is this is going to open up. It's going to start opening up on the panel, or you might even start distorting and overlapping itself. So that's why you want to trap it. So I start by tacking the ends, and then we'll work our way down the panel, and I'll put a few tacks, which I'll do real quick before we start welding. One thing you want to make sure, especially with the TIG, these magnets are great because they're really, really strong. But if we try and weld too close to these magnets, they're going to actually pull the weld, especially with a TIG welder. It's going to just throw off the arc and make it do all kinds of crazy stuff, and you'll have trouble even getting a puddle to start. So you want to stay away from it. I generally stay 3 to 5 inches away if possible, just to be safe. You can get a little closer than that. With a MIG, you can probably get closer than a TIG. But I try and at least stay 3 inches away when I'm welding to be safe when I'm using the TIG welder and these magnets. So we got our magnets set up. The other thing I want to show, and we're going to do it under the helmet in a few minutes here. Filler rod is very, very, very important when it comes to thin gauge. When we're welding something thick, like when we're doing the videos on the intros to TIG welding, I usually have 1/8 inch or 1/4 inch plate, and the filler rod doesn't really matter too much if you can manipulate it to get it to do what you want. But on sheet metal, it's very, very important. So normally what we sell the most of is this 1/16 and 3/32 filler rod. That's kind of the standard that people use quite often for welding, or 1/8 inch rod. But these are the two that we stock and carry. These I would not use for sheet metal. I don't have any reason to use these. Maybe the only time would be if you have to absolutely fill a hole or something, you could. But probably that's an issue with your panel prep that should be addressed before you're filling a hole with that. What I like to do is you can either order it in bulk, you can order thin gauge filler rod, or if you have MIG spools laying around, and that's what I did here, you can just run a piece of MIG wire off your MIG welder, or if you have a spare spool, you can keep it around and cut a piece off as you go. This is 20 gauge, which to refresh my memory, I looked up beforehand, I believe it was 035 for 20 gauge, and this rod here is 030. So the key that you want to remember is you want your filler rod to melt either before or at the same time as your base material that we're welding. So if we were welding with this 1/16 or 3/32, it takes a lot more amperage or heat to melt this rod into the panel. So what's going to happen is it takes more heat to melt this than it does your panel. So you're going to start opening up a hole or melting through your base panel before you even get to melting the filler rod. So what you're going to be doing is then trying to heat the rod. It's going to cause issues and just not be right. So try and match it as close as you can. You can get 035 if you bulk order, but I think you have to buy it in, at least here locally, 10 or 20 pound boxes, which if you're not doing a lot of sheet metal is kind of a pain. So you can just use your filler or your MIG wire. If you look on your MIG wire, it's the same thing. The sticker is, we've been using this for a while, but you can see on this one, ER70. It's basically the same exact, if you look on your filler rod that you have at home for welding steel, your TIG rod, it's going to say the same thing, or you can even look on the end and it'll say ER70 on there. So it's basically the same thing. You don't have to worry about really any issues. So we got our panel set here. Pull this close. I'm going to put a few tack welds just to keep it from moving around. Then I'm going to show you using each of these filler rods so you can kind of see what has to be done to get the filler to melt in. I'm also going to show you welding next to one of these magnets and what it looks like so you can keep it in the back of your head when you're too close to your magnet, what's happening. So put my gloves on here. And then we have Joe, the man's the mobile camera here. He's got a little lens set up that we MacGyvered together that he can actually see the weld. So we're going to do a little under helmet welding. You can actually see what's going on. Now this metal comes in our kit, comes as an aluminized metal, and the aluminized is okay for welding MIG welding, but if we're welding steel, that aluminized coating kind of messes with the TIG weld and causes some contaminants. So what I did is I took a DA sander with 80 grit, went over the whole panel, DA'd everything, got that coating off, And I even did the edges a little bit just to make sure there was no residual coating on the edges of this where it was cut. So you want to make sure your panel is as clean as possible. Use acetone, use our low VOC pre, and a scuff pad or a Scotch-Brite. Scuff the panel real good with that one last time before you're about to weld, just to make sure you don't have any contaminants, because you really only get, you don't get much chance for error when you're welding thin gauge stuff like this. Do you have any questions before I start getting into welding at all?
Most of the questions I've been able to answer here so far. So
awesome. So like I said, I'm going to put a couple tacks here, and you'll see what I do with the magnets just to keep away from them. So I'm going to move them. I already put one on the end here, so I'm going to move this over and do another one right in here. Now we could fusion weld this together, or we can just add a little dab of filler. Depends how what you're doing and how comfortable you are. And I'm going to move over just a little bit, just making sure everything stays kind of where we want it. So all I'm doing is I'm heating up. It's probably tough to see right now because we're tack welding such a quick thing, but I'm putting heat and getting just a little tiny puddle started on the base material, and then I kind of just I lay a piece of filler rod in. It flows out in the seam, and then I let off the pedal. You want to be in and out as much as you can so that you don't have hardly any heat in the panel.
Hey, before you get started here, we actually have 2 questions that might go into what you're about to do. One is, do you need to move around when you're welding this like you would with MIG welding? So, and 2 is, are you using a foot pedal? So maybe Joe could show that.
Cool. So the first question we had was one that is a common one. I kind of jumped over it, so I'm glad somebody asked it. Do you need to jump around when you're MIG welding, or when you're TIG welding, like you do when you're MIG welding, what people generally do? The high-end answer is you should be able to weld. I don't want to say high-end. If your skill level's there and the panel is prepped perfectly and you have enough filler rod, I would run this panel from one end to the other in one shot and weld it all in one go. That's all in your skill level. Metal warps no matter what. As soon as you put heat into it, it's going to warp. I don't care what snake oil trick that you try with water or an air gun, it's going to warp to some effect. Now you can use those methods to keep it down. So the idea, what causes a lot of problems with warping in a panel is the inconsistencies in the warpage. So with TIG welding, I'm not quite to the point of welding a huge long panel myself, confidence-wise, a seam that's maybe 3-4 feet long in one shot. I'm just not there, but I can weld, I could probably weld majority of this if I had enough piece here and do that. But you have to be real consistent in your weld to make sure that you're not slowing down, you're moving right along as you go and welding everything together. When you start jumping around on a panel, if I weld this, an inch here, and then I jump over here and weld an inch here, and then I come back here, you're heating the metal at a different amount every time. So when we warped it a little bit here, maybe when we came in the next time, I welded a little bit more that time and put say 3% more heat into it. Well, it's caused 3% more warpage. That's what causes your highs and lows and your inconsistent warpage in a panel by jumping around like that. So in a perfect world, if your skill level is there, weld that sucker from one side to the other, keep moving, keep the heat the same. Because what you can do is when you hammer and dolly it to reverse the warpage, you hammer on it all the same, and it releases the shrink in the panel, and everything levels out. When it's warped all funny like that, you got to hammer on this area so hard, and then this area not as hard, and it's a little more difficult. So again, I couldn't weld, something that's the length of this table in one shot, even though that would be great. But what I end up doing is I'll weld a section as much as I can in one shot, and then I'll move and weld again and keep moving, and just reposition. So you don't need to jump around necessarily, but if you're a beginner and the panel starts heating up a lot where you're not able to move real fast, then by all means stop, let the panel cool. You just have to keep in your mind, try and be consistent with the distance that you're traveling each time so that you don't have more heat in it. That's a good question. I know it was a long drawn out answer. The other question was, am I using the foot pedal? And the answer is yes. I have the foot pedal set to a max of 50 amps. The finger switch on this is a set amperage setting. I call it the tack weld switch if I just want to tack weld out of position. I left it on the torch because I don't want to cut it off because we may use it for something else. We put zip ties on it so you can just cut it and remove it without damaging it. But I just use it as a little, as just a grip or a handle when I'm welding. But I am using the foot pedal. Maybe when I do one or two of these tacks, we'll get Joe to zoom in on that as I do that. So let me put a couple more tacks, move around. So I'm just dragging these magnets as I go, so it's kind of keeping all the slack out of it, keeping the panel nice and flat as we go. There I could tell, I'll have to get that on camera next time. I'm probably, I don't know, what, 2 inches away there, and I could start to see the arc. It took me a little longer because the arc started bouncing around because of this magnet. Might be because we have so many magnets on this end. So I want to get that on under the lens so you guys can see what happens, the difference. I already welded a little section there, so we don't really need to tack. Okay. Oop. I'm gonna get rid of these magnets. They're so strong they pull my filler rod. Okay, so we'll show you this before we start getting into the under helmet, just after it's tacked. So we'll get it over here. Okay. So you could probably see that the area that's getting heated up is very, very, I mean, it's just a tiny bit bigger than what the actual puddle is when we're tack welding. But that's all you need, just little tiny tacks. I could see on this area here it's wanting to pop over a little bit, so I probably should tap that with a body hammer, put another tack in between each of these areas. But you don't want to put hardly any filler rod. We're trying to actually melt the two of these materials together as much as possible so that when we do run over top of those, there's not like a lump of filler rod. So I'm barely putting any filler rod in. But you can already see the V from the warpage in this just from me doing those tack welds already. So if you're doing a repair panel on something and you get it all tacked together where it's, you got tacks every 3 or 5 inches apart, what's a good practice is to take a hammer and dolly. I'm actually going to go grab one and do it quick, and hammer on each of those welds a little bit. Let's grab one of our hammers here. So I'm going to hammer, you know what, I'll use this area here. We're going to use the top of one of our vices here. And I'm going to hammer right on the weld. And we're hammering on dolly. And you can see I'm not hitting it very hard. I can feel it release when I hit on it. You can actually feel it kind of just relax and release. So if this was a panel in the car, you know, we'd be holding our dolly behind here like this. And be hammering on dolly just a few times. So not driving a nail in a 2x4. But all we're doing is just taking out that warp, the warping that occurred just from us. So we're kind of resetting ourselves back to relatively flat. So much better. I could probably go over and hit each of these just a tiny bit more. I mean, we want to get really picky. We could get a straight edge and get this thing dead flat again just by doing a couple more taps on it. But we're hammering on dolly on the weld. It's when you're TIG welding, the nice thing is, and you could probably get a close up here on any of these welds, you can see it actually smashes the weld down. When we hit on it on dolly, planishes the weld, it smooths it out, makes it nice and smooth in the panel. That's what you want. You don't want a big raised puddle on top that you're trying to smash down into it, because it'll take so much force to smash it into the panel that you're probably going to start overstretching it. But you can see we got rid of a lot of that warpage already just with those couple little tacks. And if this was something on a car, I'd probably go and add a tack in between each of these. But I don't want you guys watching me tack weld for 10 more minutes. Any questions before we go further?
Oh, yes. Okay. So we got a few questions here.
Cool.
What was your pre-flow and post-flow settings welding sheet metal? I got a couple more then.
Okay, the pre and post flow settings. Question was what were my settings? I don't really change them very much from what I'm doing on most other welding. I will turn it up a little bit for stainless and aluminum, but I have it at about 0.2 for the pre-flow and just a little over 3 for the post-flow. Now you can use the post-flow will also help cool the weld a little bit if you keep it over top of the weld, which is definitely good. The pre-flow is just giving it a little bubble of gas ahead of time, but that was the settings. Good question, I did jump over that.
And on Dan would like to know why you prefer TIG welder. What are the advantages of TIG welding over MIG welding?
Okay. Good question. We get this one pretty often. Why do I prefer TIG welding over MIG welding? Especially for sheet metal, TIG welding is a lot more controlled, less spatter. You can really see what you're doing. You get a cleaner fit. The other nice thing is a MIG weld, you can't really hammer and dolly a MIG weld like I was doing there, or we would do over this whole panel, because a MIG weld tends to be brittle. So if you hammer and dolly it, it's really hard. So I couldn't just do what I was doing there and smash the weld down and make it like perfectly flat. What would happen is if you hammer on it too much, it's just going to crack. So it'll crack. Like if we were doing this to the same panel that we tack welded with a MIG welder and I hammered it on dolly like that, you would have probably saw these welds started to separate and they would have popped loose from the panel. So you can planish a TIG weld, which means you can hammer and dolly it and smooth it out and manipulate it Where a MIG weld, you get what it is what it is. You can't hammer and dolly the weld too much, or it does crack. The other thing is it's just a cleaner looking weld. For anything you're doing, a TIG weld just looks a little better. So if we're doing general fabrication, I like it because it's a cleaner weld. But there's most definitely instances where you would want a MIG welder probably over a TIG. Some of the heavier fabrication, a MIG welder is just much easier and it's completely acceptable. And if you look at heavier chassis fabrication, a lot of times the guys are using MIG welders just because it works a little better than a TIG welder. So I would say whatever you're comfortable with is okay, but when you start getting into sheet metal work, especially, and you're trying to shape a panel and hammer and dolly or possibly even run this seam through an English wheel, you need to move to either an oxyacetylene or a TIG welder because the weld's softer, you can manipulate it. Good question.
Can you weld cast iron with this TIG welder?
Cool, good question. Can we weld cast iron with the Eastwood TIG Welder? Answer is 100% yes. We had a couple videos where I was building a Model A hot rod, and I did it most recently on that. I had a 37 Hudson steering box, and I cut the flange off. It's a cast box, and I wanted to weld a mild steel flange onto it that fit inside my chassis. This welder can 100% do it. It's all in the user. Are you up to the task skill level to weld it? And B, it's all in the preparation, either the preheating and post-heating or cool down of cast iron or cast, I'm assuming you mean cast iron, is very important. I don't care how good of a TIG welder you are, if you don't preheat the piece and let it cool down gradually and use the right filler rod and the right settings on your welder, it's going to crack. Your technique can be good as far as the welding it, but all those other things come into play and that's where it starts to crack. So if we tried to just use this mild steel rod that I was using here, we have here, and I was trying to weld that mild steel piece to the cast iron piece, and what will happen is it'll just, as soon as you get done welding it, the weld will crack right down the center. Actually, here it go ting, and you'll look, you'll have a hairline crack. You need to use a different filler rod. You can get away with using a stainless filler rod, or you can get specific rod for welding cast. And you need to preheat the part and get it nice and hot. And then as soon as you're done welding it, you need to take the part and you can either put it in sand or you can put it back into an oven and slowly back the heat off for anywhere from an hour, a couple hours to half a day, depending how big and dense the cast part is. But yes, machine can do it, no problem. It's just all in the crap that's, to actually get it done, that's a pain. Any others? Cool. Good questions, guys. I'm liking these. So, got the panel tack welded together. So now I'm going to do a little section like normal, and then we're going to just show you kind of the stuff that can mess you up along the way. So I'm going to use these magnets just to hold the ends together. We'll go here. So I'm going to start from the left for my tack here and work together. So Joe, you'll probably, I think we're ready for under lens, under helmet. The only thing that's a little bit of a pain with the MIG wire is it's kind of retains that memory of being in the spool, so it's a little bit of a pain sometimes to straighten it out. I've seen guys put a couple of these together on like a drill or something. You spin it and it kind of takes it out, but we should be okay for what we're doing here for these little project here. Let me use this one. It's not fighting me. Torch. So again, using the foot pedal, is that an alright spot you can kind of get in? The arc's going to be really small, so it's going to be. I'm going going to weld a little out of position here so Joe can get what we're doing. All right, ready?
Ready.
So you can see I'm not using any filler rod here. Got my filler rod in the area just in case. Oh, see how holes opening up there. We're going to let off on a little. So the majority of that I wasn't using a filler rod at all. What happened is I didn't have enough tacks here and it started to open up. The weld started separating because we don't have, I should really add a tack between each of these. So it started to move a little bit on me and that's where I had to add a little filler rod to fill that hole. But you could see I wasn't using any filler rod. I was just kind of weaving not weaving, but I was just moving the puddle back and forth and I was just melting the two of these pieces together because our fit up is so nice. I don't really need to add filler rod. It's just kind of blending the two of them together. We can look at the back side here. Except for that spot that's starting to open up on us. You know, we're getting nice penetration through there. So, but you can see it's got some warpage, but if you look, what's important at looking at here is the actual heat affected zone. Look at how small that is. See, there's a little bit out here, there's like 2 rings. There's our outside ring where it was just starting to heat up, but here's our area that's actually, what I'll say is warping metal in this ring here is really tight. So that's pretty good. I mean, we're not putting much heat in. I mean, you could see I got my hand right on there already and it's with a glove, but it's not scorching hot, it's not red hot. And we can kind of reverse this real quick. There, you can see that's this section we just welded. You can see how it was all warped there in the beginning. It's almost dead flat again. And I don't know if Joe, you can get should have a straight edge here. But you can see that weld is perfectly flat. I mean, that does not need any grinding. You could wire wheel that and be done. So that's nice and flat, and all I did is that little bit of hammering you saw right there, that reversed that warpage, and we're ready to go. So some people like to, if you're going to jump around, and it's good to do that in between each little session. So if you weld a section like we just did here, hammer and dolly it, let it relieve the pressure, take the warpage out, and then continue on your way. At least that way you're slowly working the panel and you're not getting out of control. That's the key, is not getting out of control when you're welding something so that the warpage is just so crazy that it's hard to read it. Especially if you're just starting out, it's hard to understand why things are doing what it's doing. So we got a nice flat area there. Weld is pretty much right the same level as everything else. Panel still could use a little hammer and dolly work there. So that's the way to do. I'll maybe do another one at the end if we have time. But I want to show you guys with a different filler rod, the difference that occurs. So I'm going to use 1/16 here. We're going to go back. Same settings on the machine. I'm going to start it a little further down. If we were welding this panel again, I would start right back where we stopped. Back step just a tiny bit and then keep moving. But from here on out, I'm just going to show you guys a couple things if you're using the wrong filler rod, the difference that it's going to occur. All right. So I got to almost max that pedal out to get that filler rod to go into there. I'm actually pumping the pedal to
keep it controlled. You can already see it starting to open up on us.
So with the 116, I can play with the pedal. We're getting penetration, that's for sure. It's almost at the point of blowing through at some of these spots here. And the warpage is quite a bit bigger. You can see just the weld puddle in general is probably twice the size of what we had down here. So because of that, the heat area is probably twice the size because the puddle's twice as big. We're heating up a bigger area, we're warping more metal. That's going to cause that problem. So, good. Let me hammer on it. Just keep this all, doesn't turn into a pretzel by the end here. So that one obviously took a little bit more hammering. I got it back to flat, or fairly close to flat. But you can see in here, not nearly as nice. There's stuff that's sitting on top that I couldn't smash down. So when we go to sand this, it's not going to blend in nearly as nice as this piece is. And those are kind of highs that we're going to have to probably sand off, not going to be able to just hammer them flat. So that's with 1/16. Let's quickly go to 3/32.
Hey Matt, before you get started here,
Yes.
Adrian on Facebook wants to know if you can show what you're doing with the torch. Are you moving it straight, or are you going back and forth a little bit, weaving?
Okay, good question.
Or both?
Yeah, so we had a question of how am I moving the torch? Am I weaving it back and forth? So when I was fusing everything together and I wasn't using any filler rod, I do kind of weave it back and forth. And what I'm doing is just kind of blending the metal together. So I'm just kind of going back and forth and just kind of pushing that puddle around to make sure that I get the whole seam. Because the seam is really, really small. And once you start welding, it's hard to see it. So what I'll do is I'm just pushing the puddle around just a little bit. So I was kind of going back and forth just a hair, just to kind of push the puddle around. And then at the end, I saw that it was getting too hot. So I had to dab a filler rod and I had to add a little bit more filler rod. When I did it here with the 1/16, I was just going straight and just adding filler rod, but I was adding very little filler rod and I was moving pretty quick and I was pumping the pedal, and that was just to keep this controlled so that it wasn't burning through on me. So yes, it can be done, but you're putting more heat into it. It requires more user control, if you will, to keep it from burning through on you. So I'm going to move down here. I'm going to use 3/32 and show the difference with that.
Just let me know when you're ready.
Ready.
So I basically have the pedal maxed out to even melt this filler rod onto the piece. You can see it's just heating up a huge area because I got to put so much heat into it just to even get this filler rod to fall off the... Oh, there we go.
That's exactly what's going to happen. And I knew I was close, but I was trying to pump the pedal. But that's what happens here. The puddle is... I'm making this tough for Joe today. He keeps swapping the lens back and forth. So you could see, again, our puddle is even bigger than with the 1/16. And you can see that it's actually heating way out into here. I mean, if you look back at the beginning, it was very, very small. Out here, we're starting to heat way out into the center of this panel. And then there at the end, it just fell right through. I was trying to pump the pedal and keep it going, but it was taking so much heat to get this filler rod, so much more heat to get this filler rod to melt than the base material, that eventually it just fell right through. And that's what's going to happen. We didn't have any of that problem with the 030 rod because it was just flowing the same as the base material. So that sucks. It's not really a good fix for that. You can try and fill it, but we're going to have problems then. But that's a mess. But I can still hammer it. It's still a TIG weld, so we can. So I hammered it a little bit. I mean, it's flat. I mean, I got the area here that's flat, but it's just that weld seam is probably 2.5 times bigger than what it needs to be because of that. And again, I was really working the pedal to make it not fall through here in the beginning even. So if we just went at the 50 amps it was taking to burn that, we would have been melted through way sooner than that. So that's the key. Use the right filler rod. That shows you the differences in them. I think that's very important to show. And the last thing I'm going to show is just with these magnets what happens when you're too close, kind of as an experiment here. Any other questions before we do this?
Yeah, we got two fairly easy questions here. So throw them at you now. Dan would like to know, he's been pretty active today on this, so can you weld without using a rod? And Tim, who has one of our units, he said it's 5 years old, he's still going great. Cool. Tim would like to know if it's a pointed or blunt tungsten, so maybe you could just show him.
Good. So Dan, thank you for watching. I know you've been active today. That's awesome. We love seeing people that are interacting so much. So he asked, can we weld without a filler rod? In the very beginning, that first weld I did, I don't know if he's caught that. If he didn't, this is recorded. After we're done, you can go back and watch it. But pretty much 80 or 90% of the first weld that I did was no filler rod. I put a little dab in the beginning to get me going, and then all I did was just push that puddle along the seam. So yes, if you got a really, really nice weld seam that is nice, flush, tight finish, you could potentially weld the whole thing with no filler rod if you're pretty good. But you want to keep that filler rod in your hand to just add it as it needs it. If you start seeing your weld puddle open up, add some filler rod to kind of help cool it down and keep it under control. But yes, you can weld without a puddle, without a rod if the joint is fit really nice. If you got gaps, there's no way it's going to open the gap up. And it was Tim, is that correct?
Yeah, Tim wanted to know pointed or blunt tungsten, if you could show him.
So Tim had a good question about what my chip's set up to be. So I have pretty much a point ground onto my tungsten because I want my, is that better? Other way, there we go. I want my puddle and my arc to be as tight as possible. I mean, we're doing real fine detail work here, so I want to keep that puddle and heat as small as possible. So I have this ground pretty much to a point. I pretty much just grind them to a point. When you first do that, when you start welding, it kind of puts a little micro flat on the end of it, but you don't need to blunt the end off like you would for other joints or thicker material, because we want that puddle to be, that arc to be really nice and fine. That's what I prefer to do. Some things might work better for other people, but that's generally what I like to do, is that pretty sharp point on the. Cool. Any nope. All right. So we're gonna do just a little, see what happens here, and see how close we can get to this magnet and when it starts actually producing or starts messing with our weld. So I'm going to drop that piece. Oop. Okay. So I'm going to start, let's say, what's this, maybe 3 or so inches out. And I'm going to weld through here and then stop. And then I'm going to weld just a tiny bit more and stop, and we'll keep getting closer and see what what the arc difference looks like when you get close to the magnet.
All right, ready?
Action.
I didn't straighten this rod well enough. It's bouncing all over. All right. Okay.
So not too bad. Nothing crazy would happen except my filler rod's like a letter C here and was fighting me. So not too bad. So we're going to go move over a little bit again, a little closer. I'm going to weld a little section and see
when we start seeing the arc get funny. You can actually hear it getting louder. Hear it? I don't know if you guys can hear it, but acting all crazy. And it's not really letting me out of puddle. You can see it jumping. So as we're welding, I'll start back here. As we move that puddle closer, see how it's pulling the arc? It's actually pulling my arc over. So that's, you can actually see what happens, because that's something I see a discussion, guys that are bench racing over a beer, you know, that's something that you see people argue about. Oh, the welder doesn't affect the weld, or the magnet doesn't affect the weld. It does when you're too close. So you can see we were about, you know, 2.5 inches out, and it was completely fine. But once we started getting past below 2 inches, you could see it was starting to move. So a simple fix, like I was doing in the beginning, just take your magnet, slide it along, and keep yourself away from it. If you have a panel that is not fitting how you want or needs to be clamped down, and you need to weld really close to it, you can use one of our locking panel clamps. You can use, if it's something small and you're near the edge, you can use our pinch weld clamps. They work great. Or you can use Clecos. They work awesome as well. And those you can weld as close as you want to them without obviously welding them to the piece. But I want to show you guys that, something that I don't think I've ever actually really tested that closely. So, any other questions?
That is all the questions for today.
Cool. So thank you everybody for watching. Hopefully this gave you a little bit of insight into welding sheet metal. Practice these techniques on some pieces like I'm saying here, hammering and dollying them and getting stuff flat, and then just transfer that to the real part on your car, and you're going to be hitting the ground running and welding up perfect patch panels. So thanks again for watching. I'll catch you guys later next week.